Hello everyone, I am your friend Shadab Imam and currently we are dealing with the topic of CPM and PERT. In today's lecture, we are going to see another interesting problem on network crashing. So please watch this video till the end, and if you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So in the previous lecture, we have seen the basics of crashing and the terms used in crashing in detail. So if you have not watched the previous video, please go and watch the previous video. And today let us have a very quick recap of the terms we have learned in previous lecture. So in the previous lecture, we have seen that there are two types of cost in project: direct cost and indirect cost. Direct cost directly depend on the material and the indirect cost depends on the duration of the project. And we have also seen that in our problem the costs are given in the form of normal cost, crash cost and indirect cost. So normal cost is the cost that incur, or we can say the direct cost that incur when the activity is carried out in normal time, whereas the crash cost is the cost or the direct cost that incur when the duration is carried out in crash time. Now crash time is the minimum time that activity at least takes. So as for activity 1, 2, normal time is 6 days, but the activity can be completed in 4 days if we supply more resources to this, as a result of which the crash cost is greater than the normal cost. And we have also seen that the indirect costs are purely based on the duration of the project. And we have seen that to crash an activity we need to calculate one more value here, which is of cost slope. And cost slope can be given as Cc minus Cn divided by Tn minus Tc. That is crash cost minus normal cost divided by normal timing minus crash timing, or we can simply write it as delta C by delta T. That means the difference in the cost, that is difference between crash cost and normal cost, divided by difference in time, that is crash time and normal time. Now in order to calculate or to crash an activity, we need to calculate the slope, that is cost slope, for all the activities here. So let us first calculate the cost slope here. So for activity 1, 2, this is 100 minus 60, 40. 40 divided by 2 is 20. So this is 20 rupees per day. This is 140 divided by 2. So this will be 70 rupees per day. This is 100 divided by 2. So this is 50 rupees per day. Similarly, this is 20 divided by 2. This is 10 rupees per day. This is 110 divided by 2. This is 55 rupees per day. This is 220 divided by 4. This is also 55 rupees per day. This is 60 divided by 2. This will be 30 rupees per day. This is 35 divided by 1. So this will be 35 rupees per day. So we have calculated the cost slope for all the activities here. Now let us see the problem. It says that the following table gives the data on normal time and cost and crash time and cost for a project. The indirect cost per day is rupees 10 and the time is in days. So in this table there are activities constituting a project is given, their normal time corresponding to normal cost, their crash time corresponding to crash cost, and we have calculated the cost slope here. Now we need to draw the network diagram for the project, then find the critical path and determine the minimum total time and corresponding cost. That is, the after crashing, what is the minimum value of time that we can reach. So let us first draw the network diagram here. So activity 1 to 2 and 1 to 3. So we'll start from here 1 to, this is activity 2 and this is activity 3. 1 to 2 and 1 to 3. Now 2 to 4 and 2 to 5. So let this be 2 to 4 and let this be 2 to 5. Activity 2 to 4 and 2 to 5. Then activity 3 to 4. So this will be activity 3 to 4. Activity 4 to 6. So this will be activity 4 to 6. Then 5 to 6. This will be activity 5 to 6. And then 6 to 7. So this will be activity 6 to, sorry, this will be 7, 6 to 7. Now we need to represent the time, that is the normal time, crash time and cost slope here to calculate the various values. So we will represent them in the form as, first we'll write the normal cost. So for activity 1 to, normal cost is 6 and crash cost is 4. So crash cost will be in bracket and then comma slope. Slope is 20. Similarly, we'll write for each activity here. So 1 to 3 will be 4 and crash time is 2. Slope is 70. Then 2 to 4, it is 5, 3 and 15. Then 2 to 5 is 3, 1 and 10. Then 3 to 4 is 6, 4 and 55. Then 4 to 6, 4 to 6 is 8, 4 and 55. Okay. Then 5 to 6 is 4, 2, comma 30. And 6 to 7 is 3, 2, comma 35. So we have written the time as well as slope for each activity. Now we'll first see what are the various paths that constitute this project. So as we can see in this project, one of the path is 1, 2, 5, 6 and 7, and the next path can be 1, 2, 4, 6, 7, and there is one more path 1, 3, 4, 6, 7. So basically 3 paths are here by which we can reach the end of the project. So let us see what are the various paths here. So various path. So first path is 1, 2, 5, 6 and 7. So first path is 1, 2, 5, 6 and 7. And the second path is 1, 2, 4, 6 and 7. And the second path is 1, 2, 4, 6 and 7. Similarly, third path is 1, 3, 4, 6 and 7. So third part is 1, 3, 4, 6 and 7. So first of all, let us see what is the normal timing, that is the time taken by activity is normal time. By normal time, what are the time for these 3 paths? So this is the normal time. So under normal time, for first path, that is 1, 2, 5, 6 and 7, this is 6, 6 plus 3, 9, 9 plus 4, 13, 13 plus 3 is 16. So for first part, the time is 16 days. Similarly, for the second path, we can see that 6, plus 5 11, 11 plus 8 is 19, 19 plus 3 is 22. So second path constitutes of 22 days, and the third path is 4 plus 6 10, 10 plus 8 18, 18 plus 3 is 21. So the third part is 21 days. Now among these we can see that the path which is having the maximum duration is the critical path. So we can easily understand that this second path is the critical path for this particular network. So this is the critical path. Now the first part we have solved, that we have drawn the network for the project and find the critical path. For the given network, the critical path is 22 days. So we will write here the critical path, which is 1, 2, 4, 6 and 7, which constitute of 22 days. Now we have solved the first two parts. Now let us solve the third part. So to solve the third part, we will also need to calculate the total project cost. So what is the total project cost here? So we can see that the total project cost in normal times, because we have taken the normal time for the activities. So first of all is the normal cost. That means for each of these activities we can see that the total normal cost is coming as 470. So the total normal cost is coming as 470, and apart from this we are having an indirect cost which is rupees 10 per day, and we know that our critical path is taking 22 days. So we will have 22 days where we are having an indirect cost of rupees 10. So this is 220 plus 470. So this will be equal to 690 rupees. So let us write here one more value, which is the total project cost. So for normal time we can see that the total project cost is coming as 690 rupees. So for normal cost it is 690 rupees. Now let us see which activity we need to crash here. So first of all we need to understand that we will always crash the critical activity, because by crashing the critical activity we can shorten the duration of project, and if we crash a non-critical activity our project may not be compressed or the duration of project may not be reduced. That's why we will always we will always crash the critical activities only. So as of now this is our critical path, and this critical path consists of activities 1, 2, 2, 4, 4, 6 and 6, 7. So among these activities we need to select which activity we need to crash. So in order to select the activity we will see the cost slope here. So among these the activity which is having the least cost slope, that means the least increase in the cost per unit time. So this is 20, this is 50, this is 55 and this is 35. So 20 is the least value, and now it has been decided that we are going to crash activity 1, 2 because it has the least slope. But for how many days we are going to crash the activity? So it is the normal time here is 6 and the crash time is 4. That means we can crash this activity for 2 days. But when we are watching here, we can say that our critical path consists of 22 days and the next path is having 21 days. That means we can only crash this activity for 1 day, because if we crash it for more than 1 day, then our critical path will change. So we will crash the activity 1, 2 by single day, or we can say by 1 day. So let us write here first crashing. For first crashing, we will crash activity 1, 2 by 1 day. So we will crash activity 1, 2 by 1 day, and since we will crash this activity, now this time will reduce from 6 to 5 days. And now let us see the timing for each path again. So first path, this is 5 plus 3, 5 plus 3 8, 8 plus 4 12, 12 plus 3 15. So this time has been changed to 15 days. So after first crashing, this time has been reduced to 15 days. And for second path, it is 5 plus 5 10, 10 plus 8 18, 18 plus 3 21. So this has been reduced to 21 days. And the third path, as activity 1, 2 is not a part of the third path, the time duration does not change, so this will remain as 21 days. And now we will again calculate the total project cost here. So the new project cost is equal to the previous cost plus crash cost minus indirect cost. So the previous cost, before first crashing, we have calculated the timing which is based on normal time, and this is the corresponding cost. So the previous cost here is rupees 690. So this will be rupees 690 previous cost plus crash cost. Crash cost, we have calculated the slope here. So we can see the crash cost is increasing the cost by 20 rupees per day. So this is 20 multiplied by number of days we are crashing the activity. So we are crashing this activity by 1 day. So this will be into 1 minus indirect cost. Indirect cost is the cost reduced per day. So 10 multiplied by the activity crashed by number of days. So activity is crashed by 1 day. So this is 1. As a result, the total cost will change up to 700 here. 700 rupees. So now after first crashing, the total project cost is 700. Now again we will try to crash the activities, and we can see now that there are two critical paths, because these two paths having the same time which is maximum. So currently we are having two critical paths, that is 1, 2, 4, 6 and 7, and 1, 3, 4, 6 and 7. So among these activities, activity 4, 6 and 6, 7 are common. That means if we crash any of these two activities, then it is applicable to both the paths. That means the time reduced will be reduced in both the path. And if we choose among these activities, suppose if I choose this activity, then along with this we need to crash either activity this or this, so that the critical path duration will be reduced. If we crash only single activity this or activity this, then this duration will remain same, which is equal to 21 days, and our cost does not reduce, or the indirect cost does not reduce. So let us see here. So for this particular network, we can see that either we can crash. So the minimum slope is having activity 6 and 7, because if we choose this particular activity for crashing, as we can crash this activity by 1 day, but if we choose this activity along with this, we need to crash any one of these activities which are having greater cost. Suppose if I choose this activity and this, that is activity 1, 2 and 3, 4 to crash simultaneously, then the cost slope is 20 plus 55, which is 75, which is way above this value of 35. So in this particular crashing, we are going to crash this activity which is 35. So let us see. In second crashing, we are going to crash activity 6, 7, and we can see that this activity can be crashed maximum by 1 day, because normal time is 1, crash time is 2. So crash activity 6, 7 by 1 day here. So we are going to crash this activity by 1 day, and after crashing this activity, this time will be reduced to 2, and once this has been reduced to 2, no more crashing can be takes place here. That means we need to show this by drawing vertical lines, and this representation shows that this activity cannot be crashed further. And now again we will calculate the timings for each path. So after second crashing, we can see that the timings are 5 plus 3 8, 8 plus 4 12, 12 plus 2 14. So this will be 14 days. Similarly, for second path, this is 5 plus 5 10 plus 8 18, 18 plus 2 20. So this will be 20 days. Similarly, third path, 6 plus 8, 6 plus 4 plus 6 10, 10 plus 8 18, 18 plus 2 is 20. So this will also be reduced to 20 days. And now we will calculate the new project cost. So the new project cost is the previous cost, that is the cost we have calculated after first crashing. So this will be 700 plus crash cost, and we can see here the slope is 35. So this will be 35 multiplied by number of days, and we can see that activity 6, 7 is crashed by only 1 day. So this is 35 into 1 minus indirect cost is 10. So this is 10 into 1, and this will become rupees 725, or we can say 725 rupees. So after second crashing, our cost of project is rupees 725. Now again we will see that we can crash further in this network. So we will try to crash again, and we'll see that now again these two paths are having the same time, which is maximum of 20 days. So again we need to crash these activities. So if we crash this particular activity which is having the slope 55, then the timing of both the paths will change. But if we select any one of these activity, then we need to select the activities along with this for other path. So let us see here, if we crash this activity, the crash cost is increased by 55, and if I crash this activity with this, so this will be 20 plus 55 equal to 75. So our crash cost is 75 if we crash these activities together, and here it is 55. So it is clear that for third crashing we are going to crash activity 4.6. Now we can see that here this activity has the normal time of 4 days and the crash time of normal time of 8 days and crash time of 4 days. So this activity can be crashed maximum of 4 days, and we can see here that the difference between the second path is of 6 days. That means we can crash this activity for 4 days, because if we crash this activity for 4 days, the timing of these two path will become 16 and 16, which is still is the maximum time or greater than 14. So we can crash activity 4.6 by 4 days here. So let us crash this activity by 4 day and see what will happen here. So this will be crashed by 4 day. Now let us calculate the timing after third crashing. So this is third crashing, and after third crashing we can see that the timing for first path is 5 plus 3 8, 8 plus 4 12, 12 plus 2 14. So this will remain 14 days, and for second path this is 5 plus 5 10, 10 plus 4 14, 14 plus 2 16. So this has been reduced to 16 days. Similarly, the third path 4 plus 6 10, 10 plus 4 14 plus 2 16. So this also is been reduced to 16 days. And now let us calculate the cost here. So the previous cost is the cost after second crashing is 725. So this is 725 plus crash cost. Here the crash cost, that is the slope here, is 55. That means this is 55 multiplied by the number of days by which we are crashing. So we are crashing for 4 days, so this will be 4, minus indirect cost is 10 into 4 because it has been crashed for 4 days. So this will be 220 minus 40 is 180, 200, this will be 905. So this cost is equal to 905 rupees. So after third crashing, the total project cost is rupees 905. Now as we can see here, after crashing this activity, the normal time and the crash time are same. That means this activity cannot be crashed further, and now we can show this activity by drawing vertical lines, and this shows that this activity cannot be crashed further. Now let us try to crash further. So for fourth crashing, we are having these two paths as our critical path now, because these are having the maximum time duration for the project. So we can see here that for path 2 and 3, the activities that can be crashed are 1 2 2 4 and 1 3 and 3 4. So now what we need to do is we need to select any one of these activities, and along with this the one activity from the other path has to be selected. So let us see if we crash activity 1 2. If we crash activity 1 2 and along with this we can crash activity 1 3 and 1 4. So if we crash with 1 2 activity 1 3, that means the cost slope is 20 plus 70, or I bet it is better that I can write here. So if we crash activity 1 2 and 1 3, 1 2 and 1 3, then the crashed cost will be 20 plus 70 is 90. Now if I crash this activity 1 2 with activity 3 4, if I crash activity 1 2 with 3 4, then the total crash cost is 20 plus 55, that is 75. Similarly, I can crash activity 2 4 with activity 1 3. So activity 2 4 with activity 1 3, and the crash cost will be 50 plus 70, 120. And similarly, I can crash activity 2 4 with activity 3 4. So 2 4 can be crashed with 3 4, and this will give the crash cost as 50 plus 55 is 105. So these are the combinations in which we can crash the activity. So as we can see here, the minimum crash cost is coming for this activity. That means we need to crash activity 1 2 and 1 3 together. That means activity 1 3 and the minimum cost is not coming here, it is by mistake. The minimum cost is coming here as 75. So we need to crash these two activities together. That means activity 1 2 and 3 4. So we will crash activity 1 2 and 3 4 together. So we will crash activity 1 2 and 3 4 together. Now as we can see here, activity 1 2 can be crashed by 1 day only, and activity 3 4 can be crashed by 2 days only. That means we can crash these two activities for maximum of 1 day. So crash activity 1 2 and 3 4 for 1 day. Now after crashing this will reduce to 4 and this will reduce to 5. So once this will reduce to 4th, now the normal time and crash time will become equal, and no more crashing can be done in this path. Now let us again calculate the timing for these path. So for fourth crashing here, let us see the timing for first path. This is 4 plus 3 7, 7 plus 4 11, 11 plus 2 13. So this will be reduced to 13 days. Now path 2, this is 4 plus 5 9, 9 plus 4 13, 13 plus 2 15. So this will also be reduced to 15 days. Now this activity 4 plus 5 9, 9 plus 4 13 plus 2 15. So this also has been reduced to 15 days. Now let us calculate the cost here. So as we can see, the cost for new project cost is previous cost, that is the cost after third crashing, which is 905. So this will be 905 plus crash cost. As we can see that we are crashing activity 1 2 and 3 4 together, so the total crash cost is 55 plus 20 75. So this is 75 multiplied by number of days for which these activities are crashed. So these activities are crashed for single day, so this is 75 into 1 minus 10 into 1. Sorry. So we can see that here the new project cost will become 970 rupees. So after fourth crashing, the new cost is 970 rupees. Now let us see if we can crash further these activities. So we can see here that again these two paths, second and third path, are the critical path because these two are having the maximum time. So for this, now we can crash activity 2 4 along with these two activities. So let us see what we can do here. We can crash activity 2 4 with 1 3. So we can crash activity 2 4 and activity 1 3. So the crash cost will be 50 plus 70, which is 120, and we can crash activity 2 4 with activity 3 4. So activity 2 4 can be crashed with activity 3 4, and the total crash cost will be 50 plus 55. Sorry. So this will be 50 plus 55 is 105. So this will be 105. So as we can see here, the total crash cost is small for this combination. That means we need to crash activity 2 4 and 3 4 together. So we will, for fifth crashing, we will crash activity 2 4 and 3 4, and let us see for how many days we can crash these activities. So we can see here the normal time is 5, the crash time is 3. So we can crash this activity by 2 days, but for activity 3 4 normal time is 5 and crash time is 4. That means this activity can be crashed by maximum of 1 day. So we will crash these two activities by 1 day only. So let us crash these two activities for 1 day. So the time here will become 4, and here also it will become 4. Now let us calculate the time after fifth crashing. So after fifth crashing, the time for the first path is 4 plus 3 7, 7 plus 4 11, 11 plus 2 13. So this will remain 13 days. Second path, it is 4 plus 4 8, 8 plus 4 12, 12 plus 2 14. So this has been reduced to 14 days. Now this is 4 plus 4 8 plus 4 12 plus 2 14. This is also reduced to 14 days. Now let us calculate the project cost here, the total cost of the project. So let us see here, the previous cost is the cost after fourth crashing. So the cost here is 970. So this is 970 plus crash cost. So crashing both the activities, the total cost is 105. So 105 multiplied by number of days. So this activity has been crashed by 1 day. So this is 1 minus indirect cost is 10, number of days 1. So here the total cost is 1075 minus 1065. So this will be 1065 rupees. So we can see here that the total project cost after fifth crashing is 1065. And now let us see whether we can further crash these activities or not. So now we can see here that we are still having these two paths as the maximum duration. That means these two are critical path here, and we will try to crash these two activities. But before, we can see here that after crashing activity 3 4, the normal time and crash time here are same. That means we cannot crash this activity further. So we will show this by cross lines so that this activity cannot be crashed further. Now if we wish to crash these two paths, we only have one combination, activity 2 4 and activity 1 3. So we need to crash. So for sixth crashing, we need to crash activity 2 4 and activity 1 3 together. And as we can see that this is having the maximum time of 1, that means this activity can be crashed for 1 day only, and this activity can be crashed for 2 days. So we will crash these two activities for 1 day only. So we will crash activity 2 4 and activity 1 3 for 1 day only. Now let us crash these activities. So this will become 3 and this will also become 3. So as we can see now that no more crashing is possible for this activity because normal time and crash time has become equal. So again we will show this in this manner. That means no further crashing is possible here. Now let us calculate the time here after 6th crashing. So after 6th crashing, the first path having a time of 4 plus 3 7 plus 4 11 plus 2 13. So this will be 13 days. Second path 4 plus 3 7 plus 4 11 plus 2 13. This will also become 13 days. And the third path is 3 plus 4 7 plus 4 11 plus 2 13. So this has also become 13 days. Now let us calculate the new project cost. So the new project cost is the previous cost. Previous cost is the cost after 5th crashing, which is 1065 plus crash cost. So we can see that these two activities had been crashed together. So the total crash cost is 50 plus 70, which is 120. 120 multiplied by 1 because it has been crashed for 1 day, minus indirect cost is 10 into 1. So the total cost here is 1175. 120 minus 10, 110. So this will be 1175 rupees. This will be 1175 rupees. Now as we can see here that now all the duration of all 3 paths have become equal. That means all the 3 paths are now critical path, and let us see if we can further crash the activity. So we can see here that in path 2, which is 1 2 4 6 and 7, we cannot crash these activities further. So because we cannot crash these activities further, that means the critical path of the second path, that means the duration of critical path cannot be reduced less than 13 days. So because critical path cannot be reduced now, we are not going to crash any activities further, and the minimum time to which this project can be compressed or crashed is 13 days. So the solution to the third problem, which is to determine the minimum total time. So here the minimum total time to which the project can be compressed or crashed is 13 days here, and the corresponding cost is rupees 1175, that is 1175 rupees. So this is the solution for this particular part, and if it has asked the optimum schedule, then we need to see at which point of time we are getting the minimum total project cost. So if it has asked for optimum schedule, then we will see among these crashings which will have the minimum total cost. That will be our solution. But in this part, in this question, it has been asked for minimum total time and corresponding cost only. So we will show that the minimum time here is 13 and the corresponding project cost is 1175 rupees. So I hope this is clear to you. So, and this will be the last lecture in the series of CPM and PERT, and in the next lecture we are going to see another chapter concerning with the operations research. So if you like the lecture, please share the lecture. Have a nice day. Thank you.